Welcome back. In this video I'm going to try to replace the main flex connector on this board. To begin, I'm going to reduce the melting point with 60/40 solder. At this stage it was becoming clear that that wasn't really working, and it might be due to my comically large soldering tip. It is way too big for this job, so for the next attempt I am going to try a different approach, which will basically involve destroying it with heat. Enjoy! And if you don't enjoy seeing connectors get melted off with excessive amounts of heat, please feel free to fast forward for the next 30 seconds of carnage. After what seemed like 30 minutes of desoldering and melting connectors, it's time to prep the pads by tinning them lightly with new solder, place the new connector, and then I get to break out a new toy for this one, which is a hot air station. I've never done any hot air rework before, so this will be new. Enjoy! At this point I increased the temperature and tried to get past my fear of blowing the connector away, so I doubled the airflow, and it seemed to finally work. So now that that's done, all that's left is just to clean off the board and try to reassemble it. First, a shiny new power button to replace the broken one. To continue the assembly, we'll take the main board along with its cameras, the lens frame bracket, and then move on to the back and bottom. At this point I realized that the charging board at the bottom wasn't quite sitting correctly, so after a number of attempts I was able to fit it, got the connector on. Next we'll move on to testing. With the battery and power connected, I'm first just checking to see if the phone will power on. The phone wasn't powering on, so my next step here is to check if the battery has charge, and it does. And finally, just doing a quick check without the battery to see if the phone is drawing any current, and that will be a sign as to whether or not it's alive. And as you can see here, it's not, so now we have to get into further diagnostics and troubleshooting.
No voltage. According to what I saw online, each end of this connector should carry a voltage. Should carry 5 volts, which it does not. Let's see what the other charging board has to say. See what it outputs. Power is connected. Looks like we got our 5 volts. Get this connected to the main board here. Let's see how it gives us any power. No current draw. Do our test on the battery line. Nothing. we've got 1 volt dropping. So mode, red probe on ground, 0.3. There should be ground 0.38. Little bit low. There could be something wrong with the power stage. I'll have to disassemble and try it out. The challenge will be getting under here because that's where everything is. Have to desolder the shield and then check the current sense resistors and the filter capacitors and see if there's a short or anything like that. And yeah, then we'll go from there. In the meantime, I am going to check the lower board as well. This was part of the original phone, and it was run over by a number of vehicles. So the connector felt a little sketchy. I just want to test it outside and see what do. When I ordered the parts for this board, it is actually there's a couple different variants. There's the US version, which has the lower board of what they call the M16, and then there's the international version, which is this guy here, supposedly M15. Although if you look closely here, it actually says M14. So I don't know what to deal with that. In terms of the board, this is the only board for the model that looks like. Okay, so it is outputting voltage. It's good. This thing isn't completely fried. It wasn't working on the other side. Now the connector doesn't.
Here we go again with the hot air station, trying to get at the power supply. This again took a number of attempts because these are incredibly hard to get off. The board needs to get really hot, the shielding needs to get really hot to melt all the solder bead around the edge, and I didn't have enough confidence in my ability to wield side cutters to just cut it off, so enjoy! At this point, I'm going through in diode mode, just testing the capacitors and the power supply to see if there's any shorts. I didn't see anything, but I did notice the current sense resistor, which should be a 0.056 ohm resistor, was reading about 10 times higher than it should, even accounting for my probe resistance. So the next step is to replace that. Since I don't have a SMD resistor of that value, and given the very low resistance that it should have, I've opted to replace it with a wire, aka a blob of solder. With that done, now I'm going to take the board, let it cool, reassemble it into the phone, and see if it works. And after plugging it into a power supply and prompting it to boot, we are presented with no screen and no current draw. At this point, I'm performing the same check. I am simply looking to see how much voltage is making it through that main flex cable into the board, and most of my readings are pretty much unchanged, 0.6 volts, so that means that we haven't fixed the problem and that more diagnostics are required. At this point, I'm looking for shorts on capacitors, and in diode mode I'm not seeing any new shorts or anything obvious, which is really making me suspect that the board itself or one of the main chips, which are hidden under the shields on the other side, are bad. This was run over by cars, trucks. I don't know how long it was sitting in the street when I found it, so the chances of that being the case are really high. At this point, I decided to just order a new main board and try to fix the phone that way. That said, I did want to try and improve my hot air rework skills, so I took the board to the other side and tried to reflow some of the main power ICs and remove the shields on the other side of the board, and we'll leave you with that. Comment, like, share, subscribe, and until next time, enjoy the struggle. Goodbye.